All right, number 6. This one we're going to be using the two functions. We're going to find the composition of functions, and then we're going to state the domain of each. Okay, so technically the definition for a domain of composition of functions is where they intersect or where they overlap when you compose them together. And you can also, well, if you have any restrictions, you have to carry those over with you. In this case, we may not see that. It's possible we'll see it later, but let's do the composition of functions. So in the general case, we are given our two functions, f of x, and f of x is given as 2x plus 8. And we're also given g of x. G of x is equal to 9x. Okay, the first part, A, we want to find f composed of g of x, which means we're going to take our f equation, plug in g, and this time we're not plugging in any specific number, we're just using the variable x. So this notation means we're going to replace x with g of x, which is the whole equation, which is 9x this time. So you start with the outside function, which is 2, and instead of writing x, I'm going to leave blank. 2x plus 8. So this is the f equation. Inside where x was, we're going to replace that with the whole equation gx, which is equal to 9x. So where x was, we're going to replace that with 9x. And then simplify. So 2 times 9x will give me 18x plus 8. So this is equal to our f of g of x. Now, if we go back to our previous discussions about domain, we can look at this function and we see that there are no fractions, there are no square roots, there are no logarithms, so our domain will be all real. So the function is 18x plus 8. I don't know why I wrote 18. 18x plus 18. It should just be an 8. 18x plus 8. And then we'll check that. And then our domain, we'll have no restrictions. So the domain composed of f of g of x is all real numbers. Option B. Okay, so part 2, we're going to find g of f of x this time. So we're going to do the same process. G of f of x. So my time is going to start out with g this time. G is going to be the outside function. Inside we're going to have f, and then inside we're going to have x. So we're going to start out with the g equation on the outside this time. G equation was 9x, so I'm going to do 9, and then instead of x, I'm going to put parentheses and leave it blank. In the place of x, we're going to plug the whole f of x equation. F of x equation is 2x plus 8. So inside of here, we're going to plug in 2x plus 8. And we have to distribute 9 to both of these. So that gives us 18x. 9 times 8 gives me 72. So 18x plus 72 is that expression for g composed of f of x. And then domain, we have no fractions, square roots, or logarithms, so it'll be all real. So our function is 18x plus 72. And our domain will be all real numbers. All right, then we're going to do f composed with itself. So f composed of f of x means f equation. Plug in f equation to itself. So we start out with the f equation, which is 2, and then instead of x, we're going to leave a space, plus 8. So it's 2x plus 8. In the place of x, we're going to replace the whole equation with itself. So that is 2x plus 8. And then we distribute. So that gives us 4x plus 16 plus the 8 on the outside. And that ultimately gives us 4x plus 24. And again, if we're going to find domain, no fractions, no square roots, no logarithms, so all real. And then the last part, we're going to do G composed with itself. And we have G composed of G of x, which means G outside function, G is the inside function with the variable x plugged in. So the G equation was just 9x. So instead of x, we're going to replace with parentheses, and then inside the G equation, which is 9x, 9 times 9 gives me 81x. No fractions, square roots, or logs, so all real. So that was all real domain for part C. And then we get 81x here. And then we get all real as well.